Good evening student. In our previous class I discussed about the four topics. The first one was ocean thermal energy conversion, wind power, geothermal energy and solar energy. In this lecture we will discuss about two things. First is the nuclear energy and second is the bioenergy. The nuclear energy is generated through two processes, nuclear fission and nuclear fusion. Nuclear fission involves the splitting of heavy nuclei such as uranium-235 or plutonium-239 into smaller fragments. This process releases a large amount of energy in the form of heat. Nuclear fusion. Nuclear fusion involves the merging of light atomic nuclei such as hydrogen isotope, deuterium and tritium to form heavier nuclei. This process is also a significant large amount of energy. Nuclear fission is currently used in commercial nuclear power plant to generate electricity. Nuclear fission, on the other hand, is a complex process that has not been fully developed for large-scale power generation. Scientists and researchers are actively studying and working on fusion as a potential abundant and clean energy sources, but significant technical challenges remain in achieving the sustained and controlled fusion reaction. Now, nuclear fuels. Nuclear fuels are the materials that undergo nuclear reaction such as nuclear fission or fission to produce energy. The two primary types of nuclear fuels used in current nuclear power technologies are uranium fuel and plutonium fuel. In addition to uranium and plutonium, there are fissile and fertile materials have been used to study as a potential nuclear fuels. These include thorium, which can be converted into fissile uranium-233 in a nuclear reactor. The thorium-based fuel have gained interest due to their potential abundance and reduced proliferation risks. Nuclear fuels have unique properties that make them suitable for energy generation, including their high energy density and ability to produce a large amount of heat through nuclear reaction. Now, nuclear reactor principle and types. Nuclear reactor are a complex system designed to facilitate controlled nuclear reaction. Mind it, controlled nuclear reaction, such as nuclear fission to produce heat. Here are the key principle and component involved in nuclear reactor. They are fuel, moderator, control rods, coolant, reactor core, neutron reflector, heat exchanger, shielding and control system and safety system. The principle of a nuclear reactor involve achieving and maintaining a self-sustaining chain reaction, controlling the rate of fission, extracting heat from the reactor and using it for electricity generation. This principle, along with the rigorous safety measures, are essential to ensure the safe and efficient operation of nuclear plants. Now, main type of nuclear reactor. Pressurized water reactor, also called PWR, are the most common type of nuclear reactor used for commercial electricity generation. They use enriched uranium fuel and employs pressurized water as both a coolant and moderator. Boiling water reactor are another widely used type of nuclear reactor for commercial power generation. Heavy water reactor use deuterium oxide as both the coolant and the moderator. Gas cooled reactor uses a gas such as carbon dioxide or helium as both the coolant and moderator. Liquid metal fast reactor uses liquid metal, a typical sodium or lead, as coolant. Molten salt reactor uses a liquid fuel consisting of molten salt mixture. Small modular reactor SMRs are compact nuclear reactor with smaller power output compared to the traditional large-scale reactors. Now, breeder reactor. Breeder reactor is a type of reactor that is designed to produce more fissile material than it consumes. It achieves this by using a fertile material such as uranium-238 or a thorium-232 as a fuel. In breeder reactor, neutrons from the fission process are captured by fertile material, which then undergo a series of nuclear reaction, eventually converting into a fissile material such as plutonium-239 or uranium-233. Breeder reactor offer a potential for sustainable and efficient utilization of nuclear fuel resources by producing more fissile material than they consume. However, the development and deployment of breeder reactor have been limited due to various technical, economical and proliferation issues. Now, bioenergy method to produce energy from biomass. Bioenergy is derived from biomass, which refer to organic material derived from living or recently living organisms such as plant, animal and their byproduct. Biomass can be used to produce energy through various methods, including combustion, anaerobic digestion, gasification, pyrolysis, biochemical conversion and cogeneration. This method of producing energy from biomass offer a renewable and sustainable alternative to fossil fuel, as biomass is widely available and potentially carbon neutral sources. Power generation from domestic biogas plant. The power of a biomass digester is given by E equal to eta Hm Fm into V, where eta is the efficiency, Hm is the heat of conversion of methane in mJ per meter cube, Fm is the methane fraction and Vb is the volume of biogas yield per day. The volume of biogas yield per day is equal to biogas yield into total mass of dry matter consumed. Let us take a simple example. Consider the following data for domestic biogas plant. Number of cows are 5, retention time 20, temperature 30 degree, dry matter consumed 2 kgs per day, biogas yield 0.24 meter cube per kg, efficiency of the burner 60%, methane gas fraction, proportion or fraction is 0.8, mass of combustion of methane is 28 mj per meter cube, density of dry material in fluid equal to 50 kg per meter cube. The power available from digester will be nearly equal to, we have to calculate this. So we consider these values: number of cows, okay, dry matter consumed, efficiency, methane fraction and heat of combustion of methane. So the volume of biogas yield equal to biogas yield in total mass of matter consumed. It is biogas yield is 0.24 and the total is equal to 2 into 5 as there are 5 cows. So we get 2.4. Now power equal to eta, this is Hm, this is Fm and this is the Vb. So we get 32.26 mj per day. So this is all about the course. I congratulate all of you for completion of this course. You can join my Google Classroom for additional material. The class code is 4EYNPRN. Again, thank you. I hope that you will do good in exam.